want to lead by example. All that said, our next speaker is Mr. Cas Vanwoerden. Notice there's a D there, it's not in the program. Who is a Dutch person. He is an electrical engineer who has for 18 years been living off the grid in a place that I have visited once, Animal Farm, which is what, some 50 miles northwest of Houston. And Cas takes care of making sure, like it says here, that the lights are out, and his wife Sarah is making sure that all the food gets grown. So with that, I give you Cas.
Thank you. Well, hi everybody.
Hello.
This is the last stretch. Great to have you here. Anyone was on my talk last year here in this den? Good. All right, so I can say anything I want. I remember coming to the United States from Holland, where I was born and bred in 87, I believe, yes. And it was late in the year, even though it was hot as hell. And I was walking around near a friend's house, and I heard all these air conditioners humming. And then I looked up, and I saw this incredible source of energy. And I just couldn't figure it out. So ever since, I've been on a quest to see how we can change that. And in '91, we bought a wonderful property, which is basically 70 acres of raw land. No one has ever set one foot on it. No one has ever developed anything of it, other than some crazy hunters which shot at each other. And I made a commitment to be energy independent. It started out as a weekend retreat for our family. Our children were about this size, and we had a wonderful time. And the first thing we did is we brought our horse out there, and our horse needed water, so we needed a water well. And in order to have a water well, you need electricity to power the pump. So we had a well drilled, and I told the guy, don't worry about the pump. And he looked at me like, where's he gonna go? So I just let him go home, and then I bought online a very efficient battery-operated pump, which was specifically designed to run off solar power. And there we were. 2 panels in the grass, 2 batteries from Walmart right next to it, total investment probably $1,000, and we were up and running. That was, like I said, in 1991, so we're talking about 18 years ago. Since that time, a lot has happened. First of all, we started building our house, and eventually our water needs increased. But more importantly, my wife started to grow our own food, and she needed to irrigate. We're very sandy soil, so we basically need to irrigate almost every time when it doesn't rain, which is quite often in this part of Texas. So I just added another 2 panels, laid them right next to it, and went to Walmart and got another 2 batteries, and we had double the amount of water. And then one day she got a visit from a chef, and he said, you know, that's mighty fine food you grow in there. Do you mind selling that to me? And she said, yes, of course. So next thing she comes back to me and said, I need more water. So I realized we need more power, and up went another 4 panels. I decided to hoist them up to a cedar tree so they get a little bit more sun. And things kept on growing from there every year. 4 years ago, we started the first farmers markets in Houston. It's pretty amazing that a city of 4 million people didn't have a farmers market. So today there's about a dozen in Greater Houston, and we run a few ourselves, and we supply to some others, and we do the same in Austin. And we supply to several restaurants in both the Houston and Austin area. We supply to people like Greenling, who delivers door to door. locally produced organic produce. So an ever-increasing demand for water and therefore an ever-increasing demand for electricity, which I had to produce. Let's take a few steps back. We've got an hour, so I want to talk a little bit about how we use energy, because that's really, to me, one of the most important things of this whole subject. And I don't know if you guys can see this picture, but if we just go by the proportion of the bands, then I can explain to you that on the left, we show the sources of our energy. And on the right, we show the uses of our energy. So we got this big thing here, which represents petroleum. We have this black thing here, which represents coal. We have the blue one here, which is natural gas. And we have nuclear here right on the top, and then biomass, another, which includes renewables. Well, that's not that much of a novice, but on the right of the picture, I got a shock when I saw this first. The top gray bar says rejected energy, and then the yellow one below says useful energy. And this gray area is almost twice as big as the yellow area, which means that we're wasting 2/3 of the energy we produce before we ever get to the point of trying to use it. So when I saw that, I realized that we're on the wrong track. And this is an excellent example of why. And I want to just tell you a few things which may make you understand why this is. This block in the middle, which says electricity generation, it's even worse. Here it looks like maybe only 20-some% is actually useful energy, and the gray bar is almost 75%. What happens in an electric power plant? Does anyone know how that thing works? What do we use to make power?
Coal.
We begin with heat because we want to produce steam. Almost all power plants work that way. So we find some kind of fuel, whether it be coal or gas or petroleum or anything else which will burn, and we try to basically boil water and generate steam. So what we then do is we capture the steam and we funnel it and we push against a big wheel, like a water wheel. This is a steam turbine wheel. And once this wheel is turning, we put a belt around it and tie it to a generator just like you have in your car. And that's a power plant in very simplistic terms. Now if you think about this, how much of the fuel actually goes into creating the heat? Probably not all. Some of it is wasted. Then once we have this water at a boil, do you think all of it goes to producing steam? Probably not. Do you think we can capture all the steam? Probably not. What do we see when we see a power plant? We see a big vapor cloud. Well, that wasn't the intent of the power plant, so that's a waste. Once we have that wheel turning, do you think that wheel has resistance to being turned? You bet. You think that electric generator is 100% efficient? No. So when we add up all these guys, here's the answer. Bad news, 75% lost. So that's a very poor way to get started. I want to address one more point because it's extremely important in our daily lives. I mean, we've all come here in motor cars, I assume. Most of us anyway. This block here is called transportation. Now this was bad. Look at this guy. The gray area is probably more than 75% here than the yellow, which is the useful energy. All comes out of petroleum except a tiny little bit of natural gas. And that's our motor cars. That's our internal combustion engine, which we've had ever since Henry Ford produced it. And that is by far the most wasteful way to move ourselves from A to B. Just think about what's in that car. There's this engine in the front which generates so much heat that we have to have a heat shield between it and us, otherwise we evaporate. There's this tailpipe in the back which spits out fumes, hot as hell. As a result, when we put in our $3 a gallon gas, which we think is expensive, but wait till you go somewhere else and you pay 10, that will change your driving habits. So all in all, we're on the wrong track here as well, which I think is beginning to register. We're beginning to see hybrid cars here in the last couple of years, which is a step to the solution. The solution to transportation is electric.